friends, welcome to Tech with Mahendra. Today we are going to start our new playlist that is RAG Master series. Over the next 32 videos, we are going on a journey from complete RAG beginner to building advanced agentic RAG systems that can reason, plan, and can make decisions. Today we are starting with the fundamentals. What exactly is RAG? Why does it matter? And how it's solving some of the biggest problems in AI today. So let's get started. Picture this scenario. You are using ChatGPT or any other AI tool and asked a question like this. What's the latest update on Tesla's stock price? Or what did my company CEO say in the yesterday's meeting? The AI responds something like this. I don't have access to real-time information, or in first case, it gives you outdated information from its training data. This is the fundamental limitation of traditional LLMs. They are brilliant students who studied everything up until a certain date, but they cannot access new information or your private information. This is where RAG comes into the play. RAG stands for Retrieval-Augmented Generation. Let's break it word by word. The word retrieval. It's like process of finding relevant information from a knowledge base or database. Think of it like having super smart librarian who can instantly find the exact books and pages you need. Coming to the word augmented. This means we are enhancing or improving the AI's capabilities by adding external knowledge to it. We are not replacing innate intelligence here. We are just adding some extra information to the model. Coming to the word generation. This is what the AI does best, generating human-like responses based on the retrieved information, combining with its retrained knowledge. So, RAG is essentially giving you AI assistant, a research team that can instantly find and provide relevant information to answer your questions more accurately. So let's come to the main part of the video, how RAG works. Let me walk you through exactly how RAG works with a simple example. Let's say you are asking about your company vacation policy. The RAG system searches through the company HR documents, employee handbook, and recent policy updates and extract the relevant context based on the question you have asked it. The LLM takes the relevant context and the user question and it will generate the output. The key insight here is the AI isn't it guessing or relying on potentially outdated training data. It is giving you answers based on actually what is there in the knowledge base. You may ask me a question like, why RAG? Why can't we use technique like fine-tuning or prompt engineering? It's a great question. Let's compare these approaches. Coming to the first technique, fine-tuning. It is like sending your AI to specialized school. You train it on your specific data and learns your domain knowledge. The advantages of fine-tuning is it will give you fast responses and a domain-specific knowledge building. It is a plus point, although it has disadvantages too. Expensive, time-consuming, and once trained, the knowledge is frozen. If your data changes, you need to retrain everything. Coming to the next technique, prompt engineering. This is like giving your AI very detailed instructions and examples in conversation. The advantages of prompt engineering would be quick to implement and no additional infrastructure needed. Prompt engineering does have the disadvantages. Limited by context window size and expensive token usage per large context. When compared both of these techniques with RAG is the best of the above two methods. We can add new documents anytime, so it will be up to the date, and no expensive retraining, so RAG is cost effective. Handle massive knowledge bases, so it is scalable. You can see exactly what information influencing your answer. So RAG is transparent, works with many domain or use cases. So finally, it is flexible. So when compared to fine-tuning or prompt engineering, RAG has many benefits which will be useful for the users. Let's look at some real-world examples where RAG is making a huge impact. The first one is customer support. Instead of human agents searching through knowledge bases for 5 to 10 minutes, RAG systems instantly find relevant troubleshooting guides, product manuals, and previously case solutions within seconds. The second use case is legal research. And the third, the medical diagnosis support. Doctors can query RAG systems with patient symptoms and get relevant information from medical literature, drug interactions, and treatment protocols within seconds. The fourth use case is the financial analysis. Investment firms use RAG to analyze earnings report, market research, and economic indicators to make informed decisions. Last but not the least, personal knowledge management. We can use RAG to search through our personal notes, research papers, and documents. Imagine having a conversation with you, saved articles and bookmarks. Pretty cool, right? The common thread, RAG turns static information into interactive and conversational knowledge. Okay, let's discuss about types of RAG systems. There are mainly three types: the simple RAG, advanced RAG, and agentic RAG. We are going to discuss about these types in depth in our upcoming videos. Now, so finally, what you will learn in this series. By the end of this 32 video series, you will be able to build your first RAG system from scratch, understanding vector embeddings and databases, implement proper document chunking strategies, evaluate and optimize RAG performance. And in the next 8 videos, you will be learning handle complex documents with tables and images, implement advanced retrieval techniques, build production-ready RAG systems, integrate knowledge graphs. And advanced skills in the next 8 videos, create self-correcting RAG systems, implementing adaptive strategies, build multi-agent RAG architectures, master graph RAG techniques. And at last, you will be learning how to design agentic RAG systems, implement planning and reasoning, build self-improving systems, deploy enterprise-grade solutions. Each video builds on the previous one, so you will have a complete practical understanding of RAG from theory to implementation. Also, make sure to check out the GitHub and Medium links in the description. I will be uploading all the code resources and additional materials and notes there as we progress through the series. In our next video, we are diving deep into the vector embeddings, the fundamental maths that make RAG possible. We will explore how text get converted into numbers, why semantic similarity matters, and you will get hands-on experience creating your first embeddings. If this video helped you understand what RAG is and why it's revolutionary, smash the like button, subscribe for the complete series, and ring the notification bells so you don't miss any videos. Or want to share your use case ideas? Drop them in the comment below. I will read every single one and they often inspire future video topics. Thanks for watching. I will see you in the next video where we will start building the foundation of our RAG expertise.